Okay, so we're gonna get started by drawing a picture of a very simple molecule, CH4. So hopefully this isn't too bad now. We gotta start by counting the valence electrons. So let's go to the periodic table. If you look at C, C is 1, 2, 3, 4 valence electrons because of the boxes, and H is 1 because it's the first box. So C is gonna have 4 valence electrons. So let's just write that down. And H is 1, but if there's 4 of them, it's going to be 4. So we're going to have a total of 8 valence electrons. So hopefully it's not too confusing. We've been doing this for a while. So next we're going to start setting up the structure. So we know that C always goes in the middle and H goes on the outside. So we're going to put C in the middle and the H is on the outside. We are going to connect the H's to the C because C is in the middle. So we're going to draw 1 line, 2 lines, 3 lines, and 4 lines. So every line is 2 electrons. And so what that means is we use 2, 4, 6, 8 electrons. So we have 0 left. And there you go. That is our structure. Okay. All right, so what we're going to be doing today is we're going to be adding on to this. So if you guys take a look at the structure, this type of structure, we call this the stick structure because, you use sticks. Okay, we call it the stick or the Lewis structure. Okay, but in real life, we know that things aren't like flat, right? When we draw something on a piece of paper, we draw it flat, but in real life, things are 3-dimensional, and that's what we're going to be learning about today. We're going to learn how to draw the 3D structure of this molecule right here. Okay. Okay, so let me tell you guys what the 3D structure of this molecule is going to look like. Okay, so if you guys remember, inside of these lines, right, these blue lines, these single bonds, we have electrons. Okay, and do you guys remember what electrons do to one another? They don't combine. If I have an electron next to another electron, what do? So they repel each other. They push each other away. So what's going to happen when we have a molecule like this is the electrons that are inside the bonds, they're going to push the other lines away. So this line is going to push this line away. This is going to push that one. And so basically everything is going to push each other away. Okay, they're going to push the other electrons away from one another. So what's going to happen is in the 3D structure, we're going to keep the middle atom the same. It's still going to be C. But what's going to happen is this line is going to push this line away. And so what's going to happen is, since it's 3-dimensional, this part right here is going to go in towards your page. So if you want to draw something going inside the page, we just draw dashed lines like this to show that this part right here is going to get pushed in towards the page. Okay, so make sure you're copying this down because this is what the structure looks like. So the dashed lines means that that part is going into the page. Okay, this one down here is going to get pushed outward, so out of the page. So to represent that, we're going to draw this triangle and we're going to fill it in. And then we're going to put an H at the end. Okay, so the dashed lines means it's going into the page. The triangle means that it's coming out of the page. And then this one right here is just going to get pushed a little bit down diagonal like this. And so this is going to be the 3D structure for CH4. And don't worry, you guys don't memorize how they get pushed around. I'm going to give you guys a little handout to take a look at that you guys can use on the quiz to see how these 3D structures look. And you'll be doing it for the assignment today. But this is what CH4 looks like 3D. Okay. Yeah. So for your quiz, you're gonna have to draw 3D structures for the Lewis structures we've been drawing. But I have a little handout that'll kind of give you the formatting. It's not too bad. Yeah, can you get the door? Thank you. Alrighty, guys. So that's what this 3D structure of CH4 looks like. Let's move on. We're gonna do a couple practice problems today just to help you guys out. And so this is what we saw from the molecule geometry. Okay, so the geometry of a molecule depends on something called electron groups. Okay, and I want you guys to write this down right here. What electron groups are. Electron groups are bonds and lone pair electrons. Okay, and I'll talk about, what bonds and lone pair electrons are in just a second. But while you guys copy that down, I'm going to pass out the handout that you're going to need for today. And this is yours. You guys can keep it. Safe one, pass it down. But electron pairs are basically just bonds and lone pair electrons. So we're going to look at the handout I just gave you in just a second, but what you guys really need to know for this unit is how to count the electron groups, okay? So let's count the electron groups on this molecule right here, CH4. So when we count the electron groups, what we're going to do is we're going to look for the number of bonds and the number of lone pair electrons, okay? So let's start with the bonds. So when you guys look at the electron groups, what you're going to do is you're going to look at the middle atom, okay? Only look at the one in the middle. Okay, you're going to ignore everything around except, or you're going to ignore all the ones on the outside. We're only going to look at the middle atom, okay? Okay, so the middle atom is C. Now, if you guys take a look at C, how many lines do you see next to C? Yeah, we see 1, 2, 3, 4 lines. That means that there are 4 bonds, okay? The bonds are going to be based on the number of lines there are, okay? So CH4 is going to have 4 bonds. Okay, now let's look at the electron pairs. We call these non-bonding pairs. Okay, and non-bonding pairs are basically just going to be the number of dots divided by 2. And I'll tell you guys what that means in a sec. But you just have to count the dots that are around the middle. So if you take a look at this molecule right here, do you see any dots around the carbon? No, no dots. That means there are 0 non-bonding pairs. So non-bonding pairs. And that number again is going to come from the dots divided by 2. Okay. All right, so let's figure out what the geometry or the shape of this molecule is. You're going to take a look at the handout that I just gave you. And what you're going to do is you're going to take a look at this chart, okay? And using this information right here, that there are 4 bonds and 0 non-bonding pairs, we're going to figure out what the shape of this molecule is, okay? So what we're going to do is we're going to take a look at this chart, and let's look at the first column. The first column talks about the number of bonds. So how many bonds do we say that this molecule has? 4. So we go down until we find 4. And how many non-bonding pairs? 0. So we go 4 and 0. And so we kind of see the shape, right, of CH4 that we drew. So the name of this molecule's shape is tetrahedral. So we're going to write that down on our paper, okay? So this molecule's geometry or its shape is tetrahedral. And we found that by using this information right here, okay? The number of bonds or the lines and the number of non-bonding pairs. And that's pretty much what your test is gonna, or your quiz is gonna look like. You're gonna have to draw the stick structure, the geometry, find the number of bonds and non-bonding, and the geometry. Okay, but you'll have this chart with you, so you don't need to memorize anything. As long as you know how to use the chart, you're good to go. Okay. Any questions? All right, let's see if you guys can try one on your own. Let's count the bonds and non-bonding pairs, okay? So we're going to take a look at this molecule right here, NH3. And what I want you guys to do is I want you guys to find the number of bonds, the number of non-bonding pairs, and I want you guys to see if you could figure out what the geometry is, the name of the shape that this molecule makes. Okay? Yeah, so try to find these three things. The bonds, the non-bonding pairs, and that'll tell you the geometry. Just take about a minute, use your chart to figure that out, and then we'll go over that in just a second. Alrighty guys, let's go over this problem. So if you guys take a look at this molecule, let's figure out the bonds first. So we said bonds are the lines, and we look at the middle atom. So if we look at the middle atom, how many lines are coming out of it?
3.
Yeah, 3. There's 1, 2, 3. So there are 3 bonds. Okay, and if we take a look at the middle atom, how many non-bonding pairs are there? So how many dots are there? 2. There's 2 dots, right? Okay, but we said for non-bonding pairs, we divide that by 2. So 2 divided by 2 is 1. So there is 1 non-bonding pair. Okay. So talking about pairs, so 2 dots is a pair. So we have 3 bonds and 1 non-bonding pair. So far, so good? So we got 3 and 1. So let's go to our chart and look up the one that has 3 bonds and 1 non-bonding pair. So if we go to 3, got 3 and 0, that doesn't work. But we got 3 and 1. And so we got the shape, and then the geometry is going to be this right here. Trigonial pyramidal, okay? So that's going to be the name of the shape. Trigonial pyramidal. And that's it. So that is going to be the geometry. And you guys can kind of see that this looks like the general structure that's on your chart. You get like a little pyramid shape thing. And so that's why it's called trigonial pyramid. Got a few more examples to go over, but does that make sense using the chart? Just count the bonds, the non-bonding pairs, and that'll give you the geometry. Okay, so just to let you guys know, this chart is posted on Canvas. So if you lose the handout I gave you, you'll always have access, and you can ask me for another copy. But let's go on to like a full length problem. And so this is what your quiz is basically going to look like. I'm going to give you guys a molecule. You're going to draw a stick, find the number of bonds, non-bonding, 3D structure, and the geometry. So I'll do the first part with you, the stick structure, just to make sure we're all on the same page. And I'll have you guys try the other one on your own, okay? But let's go over this one, SI-BR4. So if you guys take a look at SI and BR on the periodic table, SI has 1, 2, 3, 4, and BR has 1, 2, 3, 4, 5, 6, 7. So when we're counting the valence electrons, we got 4, and then BR is 7, but since there's 4 of them, that'll be plus 28, and that'll give us 32 electrons to work with. Okay, so this first part is super simple. It's just what we've been doing up until this point. And so let's draw the stick structure for part A. Okay. Alrighty. So we know that for our rules that SI always goes in the middle. And then we've got 4 BRs, so we're going to put 4 BRs around it. Okay, and then what we're going to do is we're going to connect all of the BRs to the middle. So connect there, connect there, connect there, and connect there. So we use 2, 4, 6, 8. So we got 24 electrons left. Okay, so if we look at SI, SI has 2, 4, 6, 8. So SI is happy because of the octet rule. We know that BR also wants 8, so we're going to give them 6 each to get them to 8. Because if you give them 6, there's 2 more here, so 8. And so we got 6, 12, 18, and 24. So this is what SI-BR4 is going to look like. And we used all 32 electrons. Hopefully that one's not too bad. Okay, so let's do part B now, the number of bonds and the non-bonding pair. So for this part, we only look at the middle atom. So if we look at the middle atom, how many lines are coming out of it? 4. So that means we have 4 bonds. Do you see any dots on the middle atom? No, right? So that means we have 0 non-bonding pairs. Okay, so there you go. That's part B. Okay, so using that information, we can use the chart to find the bonds and the non-bonding pairs. Okay, so we go to 4 bonds. We got 0 non-bonding pairs, and there you go. We got our shape, which is tetrahedral. Okay, but when we are drawing, let's draw the 3D structure first. The 3D structure, you can just use this general format right here. It's super simple. You just copy down exactly what we have here. We have SI in the middle. We have one of the BRs coming out from the top. Okay, we're gonna have this BR, and you can see this on your chart. It's kind of going in towards the page, right? And then this one on the bottom is coming out of the page, so we draw the triangle. And then we got a line coming out like that. Okay, so we're just copying that general format. Yeah, what's that?
You have to draw. We'll lose points if we draw it like in the picture. So like
yeah, you're gonna want to draw it the way that you have it on this. Actually, let me pull up your chart. That might be better. Yeah, this one right here. My bad. I'm pulling up the old one. Right there. So you want to copy it like that? Good question. Sorry about that. I'm using the wrong chart. My fault. My fault. Okay, but if you guys notice, it's exactly the same thing as part A, right? You're just kind of replacing the lines and the positions. All right, and then like Amir said, the geometry is the word right next to it. It's going to be tetrahedral. All right, there you go. That's how you do it. If you could get that on your own, that's pretty much what your quiz is going to look like. And your assignment problems is there. Look like that. All right, we're going to do one more together. I know. Oh. I know. So close. Okay, but do you guys have any questions on this problem right here? Okay. All righty, let's go on to the next one. Okay, so we got this one right here. I'll give you guys about 2 minutes. See if you can do part A on your own. Okay, if you can move on to the next ones, feel free to do that. But I'll give you guys 2 minutes to do part A, and then we'll do the rest of the parts together. Okay, so CH2O. So I'll give you guys about 2 minutes to try that one on your own. Parts with you. So CH2O, I'll do the counting. It should be pretty simple. Carbon is 4, hydrogen is 1 each, so it's going to be 2, and oxygen is 6. So we got a total of 12 valence electrons. Okay, we know carbon always goes in the middle, and hydrogen goes on the outside. Oxygen is also going to go on the outside here because if there's a middle, there's outsides, right? So something like, if you guys oriented it differently, again, they're just rotations, that's totally fine. Like if your O's on the side here and the H's are on the side, that's totally fine. All right, we're going to connect them together. To do that, we need to use 2, 4, 6 electrons. So we got 6 left. Hydrogen is happy, but oxygen and carbon are not. And so we got 6 electrons. Let's give them to oxygen. So if we give oxygen 6 electrons, oxygen is happy. We have no more electrons, but carbon is not happy because it only has 6. So what we have to do when we don't have enough electrons is we need to make a double bond. And so we'll get this right here. Okay, so this is part A, the stick structure. All right, let's do part B. We got to count the number of bonds and we got to count the number of non-bonding pairs. Okay, let's do the non-bonding because that's easier. How many non-bonding pairs are there? Do you guys see any dots around the carbon? No, so it's going to be 0. Yeah, make sure you only look at the middle for this part right here. Okay, for the bonds, it might be tempting to say 4 because there are 4 lines, right? However, there are actually 3 bonds. Okay, and the reason why is because if you guys take a look at these lines, right? If there's only 1 line, what kind of bond is that called? Single bond. So inside of this molecule, there are 2 single bonds. Exactly, and 1 double bond because there are 2. So that's actually 3 bonds. Okay.
It's like this on steroids.
Oh yeah. I spent like 15 seconds on these separate problems. Okay, let's move on to part C. So we have 3 bonds and 0 non-bonding. So if we look at our chart, 3 and 0 is this thing right here, this little triangle shape. And so if we want to copy down our little structure, this one can stay exactly the way it is. We can just copy it down like this. Okay, so you don't always need to come out of the page and into the page for your structures if that's what we have right here. Okay, so that's totally fine. And then the structure name is, or the shape is called trigonal planar. Planar, planar, tomato, tomato, potato, potato. Okay, so there you go. That's how you solve out the problem. And that's what you'll have on your assignment today. Yeah. Alrighty, guys, I'll give you the rest of the class to work on the assignment. If you guys want to check the answers, let me know. But other than that, good luck on the assignment.